They finally saw it. James Webb captures 14 Herculis C, the coldest exoplanet. A glimpse into the shadows, the James Webb Space Telescope unveils the coldest exoplanet ever seen. Imagine peering into the vast, dark expanse of space and finding a world so cold and distant that it challenges everything we thought we knew about planetary science. This is exactly what happened when the James Webb Space Telescope, JWST, captured the first images of 14 Herculis C, an exoplanet located 60 light-years away, shrouded in mystery for over 2 decades. But here's where it gets controversial. What does this mean for our understanding of the universe? Situated in a system that mirrors our own Sun in many ways, 14 Herculis C orbits a star that is slightly cooler and less massive than our Sun. This discovery is significant because it marks the coldest exoplanet ever directly observed, shedding light on a whole new category of celestial bodies. William Bulmer, a graduate student at Johns Hopkins University and a leading researcher on the project, explains the significance. The colder an exoplanet, the more challenging it is to detect. JWST's advanced infrared capabilities have opened up a new frontier in the study of these icy worlds. The planet's orbit is peculiarly elliptical, stretching a vast 1.4 billion miles from its star, positioning it in a realm between the orbits of Saturn and Uranus in our own solar system. This unique path offers astronomers a rare window into the dynamics of planetary orbits and their evolutionary histories. The intrigue deepens with the planet's atmospheric composition. Daniela C. Bartolez-Gagliaffi of Amherst College points out an unexpected finding. The planet's faint brightness suggests unusual atmospheric chemistry, possibly due to carbon disequilibrium, where molecules from warmer lower layers are transported to cooler upper layers more rapidly than predicted. This phenomenon provides a fascinating parallel to the coldest brown dwarfs and enhances our understanding of atmospheric sciences. The 14 Herculis system itself presents a cosmic puzzle. The orbits of its planets are dramatically tilted relative to each other, forming an X in space. This suggests a violent past, possibly involving planetary collisions or ejections, reminiscent of the early chaotic days of our own solar system. Studying these interactions gives us clues about the forces that may have shaped our own planetary neighborhood, Bulmer adds. And this is the part most people miss. The implications of such discoveries extend beyond mere academic interest. They challenge our perceptions of what makes a planet habitable and increase the likelihood that similar, yet undiscovered, cold exoplanets could exist. Could these distant, cold worlds? What is a 404 error? How to fix page not found and boost your SEO. You've taken a cosmic detour, but don't worry, we're here to help. Milky Way. It seems your quest for knowledge has wandered into the void. What's happening? The page you're searching for may have vanished into the black hole of the internet, or maybe it was just a misstep in the galaxy of web links. Here's the breakdown. The path you followed might be a wormhole to a forgotten era, outdated or broken link. The destination could be a planet that's been swallowed by a black hole, moved or deleted. Your navigation might be off course due to a typo in the cosmic coordinates, wrong URL. Don't panic. Here's how to recalibrate. Rocket reset your journey, return to our main hub at Universe Today, https://www.universetoday.com, and start fresh. Books explore the cosmos, dive into our latest space and astronomy stories at articles, https://www.universetoday.com/articles. Email reach out. If this feels like a glitch in the universe, contact us, https://www.universetoday.com/contact-us, and let us fix the stars. Lost in space. Rocket. Just like astronauts navigating the void, we all take detours sometimes. But remember, the universe is full of wonders waiting to be discovered. If you think this is a mistake, Please share what you were looking for, we'll guide you back to the right constellation. Space is big. You just won't believe how vastly, hugely, mind-bogglingly big it is. Douglas Adams. But here's where it gets controversial. Is it really a technical error, or are we just exploring the limits of human navigation? What would you do if you stumbled into a digital black hole? Share your thoughts below. The universe is watching. Milky Way. What James Webb will teach us about rocky exoplanets. Imagine a telescope so powerful, it could finally answer humanity's most burning question: are there truly other Earth-like worlds out there? That's exactly what the James Webb Space Telescope, JWST, is poised to do, and its findings are already stirring up excitement and debate in the scientific community. But here's where it gets controversial. What if the planets we find aren't as Earth-like as we hope, or the very definition of Earth-like is up for debate? Let's dive into what makes this such a hot topic. On the third anniversary of JWST's launch, researchers are reflecting on how this groundbreaking observatory is transforming our understanding of rocky exoplanets, those solid, potentially habitable worlds orbiting distant stars. For years, astronomers have catalogued thousands of exoplanets, but only a small fraction, just 217, to be exact, are confirmed to be rocky, like our own planet. That number might sound small, but it's not because rocky planets are rare, it's because detecting and studying them is incredibly challenging. Determining whether a planet is a rocky, Earth-like world or a gaseous mini-Neptune requires precise measurements of its atmosphere and composition, something that, until recently, was nearly impossible. And this is the part most people miss. The James Webb Space Telescope has changed the game. With its advanced instruments, JWST can analyze the atmospheres of exoplanets in unprecedented detail. Scientists are now able to study planets with surface temperatures around 100 degrees Celsius, hot, but not out of the question for life as we know it. By examining the light that passes through these distant atmospheres, JWST reveals their chemical makeup, offering clues about their origins and potential for habitability. The first results are in, and they're fascinating. Researchers have discovered that exoplanet atmospheres are shaped by a complex mix of factors: volatile elements delivered by comets and asteroids, atmospheric loss due to stellar activity, interactions with the planet's interior, and even possible biological processes. For example, a planet orbiting a volatile red dwarf star might lose its atmosphere entirely due to powerful stellar flares, meaning it could start out Earth-like, but end up barren and inhospitable. This raises a bold question: should we even call such worlds Earth-like if they can't hold onto their atmospheres? To make sense of these findings, scientists have introduced the concept of the shoreline. This idea suggests that a planet's ability to retain its atmosphere depends on its mass and its distance from its star. The bigger and farther away, the better its chances. But here's a twist: many stars change brightness over time, which could dramatically affect a planet's atmosphere. This means that our current models might be missing a crucial piece of the puzzle, and more observations are urgently needed. JWST's ongoing mission will be critical in filling these gaps and refining our understanding of what makes a planet truly Earth-like. Now, let's stir the pot a bit. Some experts argue that focusing on red dwarf systems is a mistake, since their intense activity might make them poor candidates for life. Others believe that life could adapt to these harsh conditions in ways we can't yet imagine. What do you think? Should we keep searching for Earth 2.0 around red dwarfs, or look elsewhere? Share your thoughts in the comments. Do you agree with the current approach, or do you see things differently? One thing is certain: the James Webb Space Telescope is opening a new chapter in our search for life beyond Earth, and the debate over what makes a planet Earth-like is just getting started. Where do you stand on this cosmic controversy?